Today, we're going to add bubbles to the liquid in our fantasy-style health meter. Let's go! Alright, so in the last few episodes, we've been building this fantasy-style health meter. It's a bit complex, so I broke it apart into several episodes. Last week, we added these ripples to the top of the liquid, and today, we're going to add these bubbles so it looks like the liquid is infused with some kind of mystical power, or maybe it's just carbonated. Alright, the most valuable thing about these series of videos is not necessarily the UI elements that we've created, like this fantasy meter, but it's the set of subgraphs that we've been building along the way. You can use these to build all kinds of different user interface elements and other 2D effects. These are building blocks or shortcuts that make it faster to achieve the results you want. If you haven't been following along with the series so far, I've put a link in the description for each of these nodes so you can find the one that you need and quickly jump to the video where I show you how to make it. So, if I add one of these nodes to the graph in today's video, you'll know where to find it. Alright, we're going to start out today in Unity, and then we'll switch over to Unreal in a minute and do the same thing there. Alright, so here is the graph that we've been building that's generating our fantasy health meter. The first thing that we're going to do today is create a new subgraph helper node called a hash. And the reason that we're making a hash node is that the bubbles are going to need some random movement. And the idea with a hash node is to generate random values from the input. So we're going to come down here to our procedural library, into our helpers folder, and I'm going to right click and pick create shader graph subgraph. And I'm going to call this hash11. And the reason that I'm calling it hash11 is because I'm passing a float value into it, and I'm getting a random float value out of it. So I'm giving it one component, and it's returning one component. There are lots of different types of hash that we could create, but this one just receives one component in and returns one component out. So we're going to go ahead and open up our hash11 subgraph, and we'll get started making it. First, we need to add two parameters. The first one's a float, and I'll just call it in. And then the second one is another float, and I'm going to call this seed. And this is a random value that we can pass in that will influence the pattern or give us a new pattern of random values coming out. So let's add our input value here. And I also want to open up our graph inspector and check this use custom binding. And for the custom input, I'm going to type time here. So now we need to create a branch on input connection node. And what I'm going to do is make it so that if nothing is connected to the input, it's going to use time as that random input value. So here's time. We'll connect it to the not connected port there. And there is our input all set up and ready. All right, we'll also bring in our seed value and combine these two values together using a vector2 node. So we'll pass our input into the X and our seed value into the Y. Now the next thing that we need to do is multiply our value by 255. And the reason that we're multiplying by 255 is because the code that we're going to use for generating our random value needs to be an integer. And so we take our float value and multiply it by 255 to get part of the way toward converting it to an integer. All right, the next thing that we're going to do is we're going to add a custom function node. And the reason that we're adding a custom function node here is because there are some operators that we need to do that don't exist in the graph. Basically, the idea here is we want to perform a bunch of operations on our data to really scramble it up and make it unrecognizable. We want to get rid of the pattern in the data so that it looks like it's random. It's really not random because there is a pattern, but we want to scramble the data up enough so that it looks like there's not. All right, so for our custom function, we're going to add a new input, and we'll just call it in. And we're going to add a new output, and we'll just call the output out. And we're going to set the type to be a string, and we're going to set the name to be hash21 because we're passing in a vector2. Oh, that reminds me. Our in value here needs to be a vector2. All right, so now I can connect our in value up here, and the only thing that we have left to do is to create our code. So for the code, like I said, we're going to be performing a bunch of different operations here to scramble up our data. And I'm just going to copy and paste this because these are some operations that have been worked on previously to generate random values. Now I know in the video you may not be able to see this very well, and so I'm going to paste this down in the description so you can use it. But basically what we're doing is turning our value into an integer, and then we're doing a XOR equal operation, and then we're doing a add, a multiply, and then a bit shift to the right, and then another multiply, and finally we're converting it from an integer back into a floating point value. All right, and what you can see here, like I don't know what the YouTube compression is going to do to this, and I hope people don't have problems with seizures, but basically we're passing in our time, and for every increment of time, it's giving us a different random value. Now time is just our default value. We can pass in anything we want to this, but it's just to illustrate that we get lots of different random numbers out of that custom function that we created. Okay, let's pass our output out. We're going to name this out and set it to float and pass it out just like that. And now we've got our hash11 helper subgraph. We're going to use this a little bit later on in the video. Okay, here we are back again in our fantasy meter, and we're going to come down here to the bottom and start adding our bubbles. So bubbles are fairly circular, and so what I'm going to do first is add a circle node. And so there we've got our very first bubble, but we need to change this up just a little bit, obviously. What we want to do is duplicate our circle so that we have a whole bunch of them. And the way that I'm going to do that is with the grid tiles node that we created previously. So we want a whole bunch of bubbles in the x-axis and none in the v-axis. So for x over here, for tile u, I'm going to type 18. And then for tile v, I'm just going to type 1. So let's see what happens if we pass this value into our circle. So I'm taking the scaled pattern UV here out of the grid tiles node and passing it into our circle node. And now you can see I've got a lineup of 18 circles, and this is what we're going to use for our bubbles. Now let's go ahead and shrink them down just a little bit. So I'm going to type in 0.0 or 0.3 for the size, just to shrink our bubbles down just a little bit. All right, so we've got some bubbles. Now we just need to move them around. And so in order to do that, I'm going to add a move node, and we'll connect up our UVs to the move node and then pass the UV raw into our circle. Now our move node is currently set to 0, 0 for movement. So obviously we're not going to get any change here, but we do need to create our movement. And we only want the bubbles to move on the y-axis. We don't want it to move on the x-axis. So I'm going to add a vector2 node here, and we're going to leave the x-axis at 0. And then we're going to create some nodes that will generate movement for us on the y-axis. All right, and this part of the tutorial is going to be fairly complex, so do your best to follow along. I don't have a super great way of explaining this part of it, but I'm going to do my best. So what we're going to do is we need to recreate these 18 channels that the bubbles are going to move in. And the way that we're going to do that is we're going to add a linear gradient. So we have a gradient that goes from 0 to 1, nice and smooth. And we want to break it up into the 18 channels. So I'm going to add a posterize node and then take our linear gradient and pass it into that. So by default here, you can see our posterize is set to 4, and we've got 4 channels, but I actually want 18 of them because we've got 18 bubbles over there. All right, now we need to take these 18 different channels and multiply them by time. So this is where we get things moving. So we'll bring in our time node and add it in here. And we'll connect it up. And you can't see it now, but each of these channels is actually increasing in value. So we've got time now. And now what I'm going to do is connect this up to a linear time node so that we can make our time loop. And this will make it a little bit more obvious what's happening. Now you can see that each of our channels is incrementing and going up and up and up and up and up. And once it gets to a specific value, maybe a value of 1, we use this loop to switch back to 0 so that our time is looping. And what this is going to do is it's going to make it so that each of our bubbles will move toward the top. And when it gets to the top, it's going to loop back around and start at the bottom of again. So that's what you can see, like each of these channels is moving up slowly. Well, let's go ahead and hook this up and see what happens. And you can see here that our bubbles are starting to move. Now we need to change some things around, obviously, because they're moving down and they're moving a little bit too slow. Let's set our linear time to -0.2. And that's going to make the bubbles move in the up direction. But they're not moving quite enough. And so we need to make some adjustments. So let's go ahead and take the posterized value here that we've calculated. And I'm just going to minimize these node previews here and compact things just a little bit to give us more room to work in our graph. All right, let's go ahead and take this posterized node here, and we're going to add the value of the posterize to our linear time here. And now I'm going to add a fraction so that, again, we make sure that our values loop around between 0 and 1. And let's go ahead and connect up the results here and see what we get in our bubbles. All right, we continue to have our bubbles moving, but they're not quite in the right range yet. So let's go ahead and expand out that range. So after our fraction node here, I'm just going to add a multiply, and we're going to multiply by 20 to expand our range. And then we're going to subtract 10 so that our range goes both negative and positive. And now that we've done that, let's go ahead and hook this up and see what we get. Okay, so now we've got bubbles that are moving all the way from the bottom to the top. And the one over here on the left side is moving the slowest, and the one over here on the right side is moving the fastest. So this is a pretty cool pattern for bubbles, but it's a little bit too regular. Like, the pattern is very obvious here, and it's very repetitive, and you can kind of the bubbles are just moving too there's too much organization going on here, basically. And this is exactly the reason why we created that hash node, because we wanted to add some randomness. Instead of having a perfect pattern to our bubble movement, we wanted it to be random. So let's come back here to our graph. And right here after our posterized node, let's add in our hash node. Oh, you know what? I just realized when we made our hash node, let's switch back over here to our hash node. We forgot to do just the last couple of things. We need to set our preview to 2D, and we need to set the path where this node is going to be stored to procedural / helpers. And now I'll save that, and what that'll allow us to do is to find the node in our graph. So we'll switch back to our graph here, and I'll hit the space bar. Now I can come here to procedural helpers and find our hash11 node, just like we need it to be there. All right, so for our hash, I'm going to pass in the posterize here. I'm going to give it a seed of 2. The seed probably doesn't matter that much. You can set this to whatever you want. And then I'm going to pass the out into our add and also into our multiply. And what this is going to do is give us some random values. So whereas before the bubble on the left was moving the slowest and the bubble on the right was moving the fastest, and now what we're going to have is some very random bubble movement. So each of these channels that the bubbles are moving in moves at a different speed, but that hash has scrambled up the channels so they're no longer organized like they used to be. All right, we're making some good progress. We've almost got the bubble effect that we want. What I'm seeing right now is that our UV coordinates are still just a little bit too uniform. Generally, bubbles have a little bit of side-to-side movement and a little bit of warping as they make their way through the liquid. And so what we want to do is just at the very beginning of our graph, we want to alter our UV coordinates so that we get some warping and side-to-side movements. So let's come over here all the way over to the left side, and we're going to add some simple noise. And this is a nice node in Shader Graph because it generates noise like this, but it's also very cheap. So I'm going to scale this noise to a value of 30, just so that we get some really kind of large and subtle noisy elements. And we need to move this into the -1 to 1 range. So I'm going to multiply by 2 and subtract 1. And then the next thing we need to do is just tone it down a little bit because the noise is a little bit too strong. And so I'm just going to add another multiply here. And we'll multiply our noise by 0.03. Just to make it so that the noise is subtle. And now I can bring in my UV coordinates and add this noise that we've created to our UVs. And what you're going to see when I add this, I don't know if you can even make it out in this UV color here, but we've just warped the UVs just very, very subtly. So I'm going to take this new warped UV set that we've created, and I'm going to pass it into our linear gradient here. And I'm also going to pass it into our grid tiles node over there. So we'll warp both our grid tiles and the animated channels that we created for the bubbles. And now let's come over here and look at our bubbles. And you can see that they're doing just some subtle side-to-side movement, and their shape is getting warped subtly as they move up. So we've got this really interesting kind of meandering, random bubble movement, and we're getting exactly what we wanted to get. All right, one thing that I will say about this bubble portion of the graph is that this is probably the most expensive part of the shader because we're using this hash value that generates random values, and we're also using this noise. So if you find that this effect is a little bit too expensive, if you're doing something on a mobile device or or you're putting this somewhere where it's really, really performance sensitive, you may want to leave out this bubble effect and just go with what we've created already. And in fact, if you want to make this even cheaper, you could also leave out these waves that we added last week and just have the flat liquid if you wanted to. But the waves and the bubbles really add some nice detail. So if you want the effect to look as good as possible, you'd want to keep the ripples and the bubbles. But if not, you can leave them out and make things just a little bit cheaper. Okay, so to add our bubbles into our effect, we're going to grab this part of our graph here where we've got our maximum node. And all we have to do is take the bubbles portion of our graph and add it in to our mask that we've created here. So we'll just connect up the bubbles just like that. And then instead of passing the maximum node into our lerp, we're going to pass the maximum plus the addition of the bubbles. Now we've got our bubbles flowing up through our liquid. And then once we mask it out, we've got some really nice bubbles inside our crystal vial there. And you can see that they're slowly making their way to the top of the liquid. And then once they get to the top, they get masked out. So that's it. We've created the whole fantasy meter effect. We've got the reflections and the specular highlight and the liquid with ripples in the top and bubbles coming up. And it looks really cool. All right, well, let's go ahead and pass our values out. So we can just connect up our output value there. And for our output here, we're just going to name this color. And we'll make it a vector 3. And we're going to add one more channel here, or one more output, and we're going to call this alpha. So we need to find the alpha value. We want to make the effect transparent wherever the vial isn't. So let's go ahead and generate our alpha. In order to do that, we're going to take our specular highlight, and we're going to find the maximum between the specular highlight and the Fresnel effect that we've created here. So we're going to combine those two, because obviously we don't want it to be transparent where we've got our specular highlight there, or where we've got our Fresnel reflections around the edges. And then we're going to take the mask of our gradient sphere here, and we're going to multiply that by the mask of the liquid. So we've got our gradient sphere there, and we've got the liquid mask coming out of our histogram scan node here. So just connect that up, and now you can see we've got the liquid here. So between the reflections, the specular highlights, and the liquid, we'll find the maximum of all of those. And that's going to give us the alpha channel that we can then output so that our effect can be transparent in the areas that are outside the effect, or where we're seeing through the vial. And that's going to give us our alpha channel. All right, we are all set with our fantasy meter subgraph. So now I could take this subgraph that we've created and add it into the middle of another effect, or just use it as it is and create this really cool looking fantasy health meter. If I wanted to make a game sort of like Diablo, where the player's health is created or indicated by this meter. All right, I really appreciate those of you that watched all 5 episodes of our health meter. I hope you've enjoyed this and that it's been useful. We created several new nodes in here. We created the waves node, and we created the #11 node. And we also used a bunch of the other nodes in our library. And I hope this is a good illustration of how useful it is to have this library of subgraph nodes that you can just chain together and encapsulate commonly used functionality to build up effects like that fantasy health meter. All right, let's go ahead and switch over to Unreal, and we'll make the health meter, or we'll make the bubbles for the health meter in that engine as well. All right, here we are in Unreal, and here's the graph that we've been working on so far. And this is what we have. Our results so far, we have our crystal sphere with reflections and a specular highlight. And we have our liquid with translucency, and last week we added this cool wavy pattern to the surface of the liquid. So today we're going to make the bubbles. And the first thing that I want to show you is a helper node, or a material function that I created that we're going to use in today's tutorial. This is called hash11. And if we open up our content drawer here and go to the helpers folder, you can see I've put this material function right here in the hash11 folder. So let's take a look at this. So for our hash11 material function, I've created an input, a scalar, and I've set the preview to time. Actually, let's just bring this panel over so that you can see what the settings are that I've added here. So my input is a scalar, and I've named it in, and I've used the use preview checkbox. And I've also created another input called seed. And the purpose of this function is to generate random numbers. It's called a hash, which basically means you pass data in and the node hashes it up and gives you something that looks random, but it's actually deterministic, which means that as I pass the same value in, I'll get the same value out every time. So I'm going to combine my input value and my seed value with an append node. And then I'm going to multiply by 255. And the reason that I'm doing that is because I want to convert my values to an integer. And the first step in that process is to multiply by 255. So now I have this node here called hash, and this is a custom node. So if I just type custom and add a custom node like this, basically what this allows me to do is to just type in code, and it'll execute that code. And the reason that I'm using a custom node here is because there are some instructions that I'm using in the code that aren't available in the graph. So you can see here I'm rounding my input value to the nearest whole number and then converting it to an integer. And then I'm doing some interesting things. I'm performing this XOR equal operation, and then I'm adding, multiplying, and doing another XOR here, and this operation here is called a bit shift. And I'm not able to do bit shifts in the graph itself, and so I'm doing it here in the code. Basically, I'm just trying to do a lot of random math operations to scramble up this data so that it's no longer recognizable as a pattern. And then right here at the end, I'm converting it back from an integer to a floating point number, and then I'm passing it out. And I'm sorry if this is kind of seizure-inducing, but basically I've set time to be the default input. So if you don't connect anything to this hash node, it's going to give you random values based on time, which is why it's blinking, because every new time unit that it gets, it's generating a random value for that. So this is the hash function that we're using today. And basically, I'm going to pass a float value into it and get a random value out. And that's what we need for creating our bubbles, because we want the bubbles to feel a little bit more organic. And I'll show you more about what I mean once we get to that point in the tutorial. Okay, so in order to create some bubbles, I'm going to come down here to the bottom of the graph. And a bubble, we're going to represent a bubble as basically a circle. So I'll type in circle and grab the circle node that we've created previously in the series. And let's just go ahead and preview this node here. So there's my circle. There's a single circle there, and it feels kind of lonely. And I actually want multiple bubbles. And so I need to change my UV coordinates so that I can get multiple copies of this circle. So to do that, I'm going to create a grid tiles node And I'm going to connect the scaled pattern UV output of grid tiles to the UV input of my circle. Now you can see that I've got lots of different copies of this circle. And I actually want 18 circles in a horizontal line. So in order to do that, I'm going to pass in a value of 18 to my tile U input port. And now I've got 18 tiles, but with 4 different rows. And I actually don't want 4 rows, I just want 1 row. So for my tile V input, I'm going to give that a value of 0. So now I've got my nice row of circles here, and these are the bubbles that we're going to use. But we need to move them around a little bit, and I also want to scale them down just a little bit smaller. So for a size value here, I'm going to give it a value of 0.3. We'll plug that into the size input port of our circles. So now our circles are just a little bit smaller. All right, now we need to move the circles around. So I'm going to add a move node here in between my grid tiles and my circle. There's our move, and we can pass our UVs into that and then pass our UVs out of that. And right now this input here for move is defaulting to 0. We're not getting anything. Now I know I want my bubbles to rise. I want them to go from the bottom to the top, but I don't want them to move side to side. And so I'm going to just go ahead and add an append here. And we'll plug this in. And for the side to side, that's the A. I don't want anything. So I'm going to add a 0 to the A. And then let's see. Just for now, just so we don't have this error hanging out here, I'm going to give this a 1. And we'll plug that in. But this is where we're going to plug into the B component here for vertical. This is where we're going to plug in our movement values. So now it's time to work on the movement. And what we need to do is, just like we've duplicated these circles here, we need to create 18 unique channels and then give each of these bubbles its own unique movement. So in order to create 18 channels, we're going to create a linear gradient. And then we're going to break that gradient up into 18 different bands by using the posterize node that we created previously. So there's our posterize. I'll pass our gradient into the posterize. And now if we preview this, you can see that now we've got 4 channels, but what we actually want is 18. So I'm going to type 18 here and pass that into the number of steps. And now we've got 18 different bands of grayscale color. So this is the point where we can use our hash, because the grayscale colors are really nicely organized here, but we actually want to scramble them up. So I'm going to add that hash node that I showed you that we created at the beginning. And if we preview the result of this, now you can see instead of them being ordered nicely from left to right, we've got kind of scrambled, random looking grayscale channels instead, which is exactly what we want. So now we need to take this and we need to multiply it by time. So we'll add a multiply here, and we'll add in our time node. And what this is going to give us, so now that we're multiplying by time, it actually went white. And the reason that it's white here is because our values are significantly above 1, because that time node is giving us some very high values. And so let's keep going, and we'll be able to see what's happening here in a minute once we add our frac node back in. So let's add a linear time node. This is going to allow us to loop that time. So we'll pass the time into our input port here. And then we're going to add, we're going to control the speed of time here with a value of 0.2. So we'll pass that in, and let's preview this node. This might give us something that's interesting to look at. So we've got these channels here, and they keep rising. Their values keep going up and up and up until they get to 0, or until they get to 1. And then they wrap back around to 0. And that's to allow the bubbles to reach the top and then start at the bottom again, so they'll loop. Okay, the next thing that we need to do is take the output of our hash here and add it to our linear time. So we'll create an add node and pass the linear time loop into that add node. And then here we'll add in a frac. And then let's preview this. Now what you'll see is that our channels go all the way from 0 to 1. And once they get to 1, they wrap back around to 0. So if we pass in the result of this into that append that we created, and then we come over here and take a look at our circles again, now you can see that we've got our circles moving, and they're rising up to the top, and then they wrap back around. But they're not moving quite enough. We need to expand their range. And so the way that we're going to do that is we're going to add a multiply here. And by the way, the reason that they're not going all the way is because we've shrunk them down so that they're very small. And that limits their range. So they are moving in their own 0 to 1 space. But it's not enough to go to the 0 to 1 space of the full image there. And so because we have 18 of them, we're going to multiply by 20, and that will allow them to go off the screen and then show up below the screen and come back on. So we're going to multiply by 20, and then we're going to subtract 10. And that's going to change their range so that they can go all the way from the bottom of the screen to the top. Now we'll just plug this into our append, and now we've got some cool looking bubbles. And they all rise at different speeds because of the hash node that we added here, where we kind of scrambled them up. If we didn't have this hash node, in fact, let's just skip the hash node for now. Let's just wire our way around that. What you're going to see now is they're in a nice, beautiful order where the column here on the left is going the slowest and the column on the right is going the fastest. That's why we use the hash node, so that we can scramble these up and make those columns in a random order. All right, we've got some nice looking bubbles, but we can go a little bit farther than this. And what we want to do is introduce a little bit of noise into this. So instead of rising in perfect columns in perfectly linear time with, perfectly round bubbles, we're going to put some noise into the initial UV coordinates to kind of make these bubbles move a little bit more organically. And the way that we're going to do that is with the noise node that Unreal provides. So here is our noise node. And the settings on this node are really important, because if you don't get these set right, it's going to make this node really expensive. This node has the potential to cost a lot unless you set these settings right. So I'm going to come down here and I'm going to set this to fast gradient 3D texture. Now, if we set this to fast gradient and turn off turbulence, that's going to make this noise generation basically as fast as we can make it. And also, I want to turn these levels down. Every level we have adds a significant additional cost. You can probably get away with 2 or 3 here. So let's go ahead and just view this noise. We'll pick Start Previewing on this one. And you can see that right now that noise pattern is really small. So we need to adjust the size. I'm just going to bring in our texture coordinates here. And we're going to scale these. I'm just going to multiply our texture coordinates by 6. And then this noise, unfortunately, it's 3D noise instead of 2D. If I had the ability to use 2D noise, I would do it. Because this one's a little bit more expensive than it needs to be, because it's doing 3D noise calculation instead of 2D. But that's what we're going to use for now. I'm just going to use an append node. Because our noise is 3D, we have to pass in a 3D position value. So I'm just going to append a 0 right there so that we have a 3D value. But really all we need is that 2D texture coordinate. So we're going to pass this in as our coordinate. And also, let's see, we want to set our scale to 1, our levels to 3, our output, minimum and maximum. Yeah, I think this is going to work great. And now we need to tone it down a little bit because right now it goes all the way from -1 to 1. And that's a little bit strong for the effect that we're going for. And so I think I will just add a multiply here and we'll tone our noise down. We'll just multiply it by 0.02 so that it's very weak and so that it just adds a subtle offset to our UV coordinates. Speaking of UV coordinates, I need to go ahead and add in our UV coordinates here. And we're just going to add this noise to the coordinates so that we noise them up so that they're not perfectly smooth like they were before. And so I'm going to take these coordinates that have the noise applied. Let's see if we can see this. Let's just preview this. I don't know if you can make that out, but these UV coordinates have been altered by the noise that we created so that they're not quite as smooth. So now I can take these UV coordinates and plug them into our grid tiles node and also plug them into our linear gradient node. And now let's take a look at our circles again and see what we get. So what you can see is that instead of like this perfectly smooth linear movement that our circles used to be making, now they're doing this sort of like meandering path because we've added this noise to their UV space. They're no longer moving perfectly smooth and linear. And we get something that looks a little bit more like the random movement of bubbles through liquid. It's pretty cool. All right, so now we just need to take our bubbles. They're basically done here. We need to take the results of our circle output and combine them with what we created for our vial. Let me see if I can find the right place to add these in. Yeah, I think it's right here where we have our max node here. Let me just take a look at the preview. Yeah, this is the right spot. So we can just add in our bubbles here. And then instead of passing max into lerp, we can pass the combination of our liquid and our bubbles into lerp. And now let's go ahead and preview the final thing. And you can see that we've got our nice bubbles in our liquid. This is cool. All right, so we've got our bubbles rising from the bottom of the liquid. And you can see that they stop right here at the edge because we've masked them out with the top of the liquid. All right, there's one last step that we need to do to finish off this effect, and that is we need to add another output for our alpha. So right now this output is our color, but we want to output an alpha channel so that it'll be black wherever it's transparent and white where it's not. So we'll call this output alpha and set the sort priority to 1. Now we just need to generate that alpha. So to generate the alpha, I'm going to take the specular highlight and find the maximum between the specular highlight and the Fresnel mask. And let's just preview this. So this is going to give us the Fresnel mask and the specular highlight. And now we just need to get the liquid added in here. So I'll take our circle mask, which is coming from here, and multiply our circle mask by our liquid mask, which I believe is our histogram scan. Yeah, so our histogram scan node here is the lower bounds of the liquid. So we'll pass that in. And now to combine these two, we'll just take the maximum. So this is combining our reflections and our specular with the mask that makes up the liquid. Whichever of those is greater, we'll return that. And that gives us our alpha channel. So we've got the liquid down here. We've got the nice specular highlight and reflections up there. And that creates the alpha channel for our effect. All right, so we're all set. We've got our alpha output and we've got our color output, and we've got a super cool effect that you could use for a health meter or a mana meter. By the way, we've been using red here as the color, but we do have an input exposed for the color here for liquid color. So if I wanted to make this a mana meter, I could make it like purple or teal or any color, any other color that makes sense. So we can make multiple meters, one for health and one for mana, or whatever we want to indicate. And we've got this cool vial that actually shows the player's progress or whatever indicator that we want to show. Anyway, I hope you enjoyed today's tutorial and that you were able to follow along as we added these cool looking organic bubbles to the liquid. I know that this part is kind of complicated. Oh, and by the way, the bubbles are just kind of a nice little visual addition, and they're not strictly required. So if you find the effect is a little bit too expensive for your application, you can definitely leave this portion of the graph out and not have the bubbles if you want, but that's completely up to you. The nice thing about this effect is it's modular, so if you want to make it really cheap, you can leave off the bubbles, you can leave off the waves, and just keep the essential parts, or you can add everything in and maybe even add some additional effects of your own to really spice this up. Anyway, I hope you've enjoyed our series of 5 videos on making this fantasy style health meter, and be sure to come back next week. We're going to continue in our series of making procedural shapes and patterns. And until then, have a great week.